PaxiTech's fuel cell educational kit for student tutorials and fuel cell demonstrations. The complete energetic chain can be seen from hydrogen production by electrolysis to hydrogen consumption in a fuel cell. The contents of the educational kit include a water electrolyzer, power supply, bubbler, 3 different air-breathing fuel cells, a load box, data logger, cables and tubing. All you need is a power socket and some deionized water. Here you see some tubing, a gas bubbler and a stopcock, and a safety valve in case the hydrogen pressure increases. Here a power supply to power the electrolyzer and a specially designed load box with a constant current or a constant voltage mode. Firstly, the safety valve and the stopcock are connected to the fuel cell gas outlet, and the fuel cell is electrically connected to the load box. The electrolyzer is filled with deionized water and is connected to the power supply. The bubbler is filled with water and the gas inlet is connected with a tube to the electrolyzer hydrogen outlet. Another tube connects the bubbler hydrogen outlet to the fuel cell gas inlet. The power supply is turned on with a voltage set at 2 volts. The hydrogen produced can be seen in the form of bubbles in the gas bubbler. The pressure gauge indicates an increase in the hydrogen pressure in the gas bubbler since the fuel cell hasn't been turned on yet. The load box shows an open circuit voltage of 1.079 volts, clearly indicating that the fuel cell is now ready to produce electricity. The fuel cell is fed with hydrogen produced by the water electrolyzer and with oxygen from the surrounding air through the slits visible on the fuel cell cover. Once constant current or constant voltage mode has been detected, the current or cell voltage are adjusted manually using the knob on the left-hand side of the load box. The electrolyzer has now reached its nominal performances and the current is adjusted to 3 amps, which corresponds to a hydrogen flow of 20 milliliters per minute. The full kit is now ready for experimentation. The voltage or the current applied to the fuel cell can be manually varied to perform experiments such as carrying out a polarization curve. The load box can be connected to a computer via a data logger to record the cell voltage and the current continuously.